Hello again, Tom from EveryStepCalculus.com, EveryStepPhysics.com. This is a partial fractions problem. Generally, you probably won't see problems like this on a test. You may see it in homework. Maybe in the advanced courses or some crazy professor will put this on here, but good luck in solving it, from memory. But given the time with your other classes to study and what you're supposed to do, anybody can study this stuff if that's all you do is study it, So anyways, you buy my programs. I've had things, people have texted me or whatever and said, I put index 8 into the calculator here and nothing happens. Well, you got to buy my programs, and then I send them to you by email, and you load them in there, and I have full instructions on how to do it, and I help you all the step in the way. If you can't do a problem, you email me or call me, and I'll help you with that or show you how to do it, certainly with my programs how to do it. And it's as simple as that. Anyways, index 8 to get to the main menu, press enter. I'm already at partial fractions, which you're going to choose because this is the problem of the partial fractions, decomposition. So we're going to choose press enter, and I show you the program. We're in the correct program, and we're going to enter the integral here, this stuff here. You have to press alpha before you enter anything into these entry lines here. So you'd press alpha, and then you'd put 8 times, x cubed, etc. Now I've already added this in there to save time because it takes a long time to put this in. Not for you for your calculator in real life, but this is a simulator, and it'll screw up at the end, may screw up at the end, and then you'll do all this, and then you have to do it all over. So I've already, and here's the problem here, already entered into my program. Remember, you have to press alpha before you enter anything in here, otherwise it doesn't go to the second register where you have numbers or letters, okay, and the keys here. And so we say it's okay. I always give you a chance to change it in case you've made a mistake, so it looks pretty good. We factored the denominator always in partial fractions to see if we can do that. If it can't be factored, you can't do the problem in partial fractions, okay? So make sure the denominator is fractable. I do that for you here. Without the calculator, you have to do it in your brain, to factor this. And because the exponent in the numerator is 3 or less and yet higher or equal to the exponent in the denominator, only short division is required. Here's the numerator exponent, here 3, and here's the exponent 2 in the denominator. This is a higher or equal to the number 2, and yet it's not over 3. 3 you have to use long division, okay? So we press enter. And we do that. We short division. We divide the numerator by the denominator and come up with 2x, okay? And I give you this help here. This quotient here will be used in the answer of your partial fraction answer. And you're going to integrate it first, come up with x squared when you integrate this with respect to x. And we're going to set up the partials now on both sides of the equation, and you do that by taking the divisor here and multiplying putting it in the numerator, multiplying it times each side of the equation. I do that. This is the left side of the equation, and then we're setting up the a's and b's. You have to use factors of this denominator here too. For a, you separate them just like this, and here we're multiplying times the divisor in the first place. Okay, that cancels a lot of things. I don't know who designed this or who. It's all absolutely useless. I haven't found any useful problem in calculus at all. 30 years I've been doing this. I haven't found any useful. This is certainly not useful. Remember, an integral is really the area under a curve. When you can go and put this in your graphing of this calculator right here, and you'll see that it's a parabola with a straight line and goes up and down and goes up and below the x-axis. Anytime you're doing an integral, you're finding the area under a curve. Now this is an indefinite integral, so there's no range for you to find the area. And so you're going to have a plus c at the end here, you know. So how useful is this, or what are you doing here? Well, you're doing, it's like taking 3 semesters of Sudoku puzzles. That's the Japanese math puzzles that you find on the back of a magazine when you're waiting for a plane to Phoenix. And then, or taking 3 semesters of crossword puzzles to get your English degree, you know. That would be a waste of time, and Sudoku would be a waste of time. Well, calculus is the same thing. Even for engineering, I'm an electrical engineer, you know. Went to San Diego State for that, and had training before I even went to San Diego State, because I went there at the age of 50. And never heard anybody use calculus for anything. You know, you can do anything with calculus because you can take anything and integrate it and come up with some sort of function, you know, with respect to x or y or whatever you're doing. So anyways, I'll get back to the problem here. We take a common denominator, and if you do that, of course, it cancels the left side of the equation because you multiplied the divisor in the numerator, and then you, by common denominator, you get this function here. You don't have to think about it, just write it on your paper, you'll be correct. And we're going to choose x to make a equals 0. So we choose that, x equals a minus half then to do that. And we substitute for x into the equations. We do the computation, and b is equal to 1 then, okay? We substitute b into the function. Here's b, we put 1 in there for that. We do the computation, here's 1, and then we change it to the other side, it becomes a minus 1. So you have a minus 4 here, and then the a here, okay? Now we substitute x equals 0, and add it to the x's, you know. We do the computation, minus 4 equals a to the 1, so a equals minus 4. We integrate everything. Integrate, here's the quotient at the beginning that I was talking about. We're integrating that, it comes up with x squared plus the integration of this dx, and this equals minus 2 log of absolute 2x plus 1, okay? And so we do the computations, and here's the answer. Minus 2 log of absolute 2x plus 1, etc., etc., etc. And there's the lovely plus c, which throws everything off, because you have somebody has to choose the plus c, so you can see how worthless indefinite integrals are, you know. Go to my site, buy my programs, and pass calculus or physics. Physics are fabulous, even better to me than the calculus ones, but anything to get through these tests because they're such worthless. If you're going to stand there and study for hours like I do, every one of these problems I have to do on a single piece of paper, do it correctly, get different opinions from professors and stuff like that, and find out the best way to do it, most common way to do problems. I have books of thousands of problems that I've done on paper, and then I can program it and I can program anything on a program on a piece of paper, you know. So good luck in your classes, and you know, buy my programs, and I'll help you all I can. I couldn't be more thrilled if you pass your class, okay? So have a good one.